Yes, dear student, I taught you about artificial satellite. I taught you how to find orbital velocity, how to find time of flight and total energy and bind energy of satellite. Now, there is one very important topic here, weightlessness in a satellite. You might have seen in pictures, TVs, when they show astronaut inside the satellite, the person inside the satellite are called astronauts. So they keep on flying. They feel complete weightlessness. So why do we feel our weight? So we feel our weight. So here this diagram is not necessary, but I have drawn this diagram. It is the satellite. Satellite of mass m. This is the Earth. Earth mass is me. Here is the astronaut who is mass I can take m. And r is the radius of orbit. Instead of r plus re plus h, actually r is equal to re plus h. This height. So I have taken radius. So why do we feel our weight? I told you while teaching Newton's law of motion, when we stand on any floor, weight of our body acts vertically downward, and normal reaction of floor on our body makes us feel our weight. When we stand, I am writing again, when we stand on any floor or platform, the weight of our body acts vertically downward towards center of Earth, not in it right. The normal reaction of flow, which is equal in magnitude to our weight, acts on our body vertically upwards. Dear student, questions, basic questions are very important. Please don't go other way. These questions are asked in competitive exam as well as board exam. And moreover, if we are studying some subject, we must be very clear. So, normal reaction. The normal reaction, यहाँ capital N होने of flow, which is equal and in magnitude to our weight, acts on our body vertically upwards. So, it is the normal reaction and which makes us feel our weight. Feel our weight. I am standing here on the floor, my weight acting downward. Reaction of floor act P1 upward, and I feel weight. If this normal reaction anyhow get changed, then weight will change. Now, in figure, a satellite of mass m, capital M, is revolving in circular orbit of radius r. To move the satellite, the satellite needs centrifugal force which is provided by gravitational pull of the earth. So, what we can write? mvo square upon r is equal to gmem upon r square. And from this equation you get here vo square r equal to gme upon r square. Don't cut r के power cancel. We need this v square r. So this is one equation which we have obtained by comparing the force centrifugal required from with gravitational pull of the earth. Now, the astronaut, the man inside, the man of mass m is inside the satellite. So the man needs centrifugal force centripetal force because he is also moving on circular path. Because he is also moving on circular path, and therefore mu square speed always will the same upon r is equal to g m e m upon r square. Again from here vo square. Oh, sorry. And normal reaction is this n. By the floor, he is standing in the floor of the. So normal reaction of this satellite act vertically up and the center greater pull of the earth downward. So we can write if n be the normal reaction of the floor of satellite on the man, then we can write what? Uh, MVO square upon R is equal to central force required will be equal to GMEM upon R square minus N. Because by this way, pull of the earth acting downward toward the center and near motion upward. The resultant of these two forces will be equal to will provide central force. And from here, from equation 1, VO square by R is this. Using equation 1 here, M into VO square by R, GME upon R square is equal to GME M upon R square minus N. This is GMEM, this is also GMEM. From this they get cancelled and become 0. The normal reaction of the fluid becomes 0 here. In fact, the weight of man actually is balanced by central force required. I have proved it other way, but simply whatever the force of attraction of the earth on man, by our weight, what is our weight? Our weight is the force applied by earth on our body. The man in the satellite, here distance r, so some acceleration to gravity will be there, so its weight will be there mg dash. So that mg dash weight, he needs central force. Is balanced by central force, so weight becomes 0 automatically. So here I explain in terms of normal reaction, because it's basic definition. It is the normal reaction of the floor where we stand that makes feel our weight. So normal reaction becomes 0. But we are always remain in hurry. When I ask students, actually we have tendency not to study well, and we keep on telling from our small knowledge, we apply small knowledge. When I ask why there is weightless satellite, they say their gravity is 0. If gravity is 0 at the site of satellite, then how the satellite is moving around the earth? It is the gravitational pull of earth, which we call gravity of earth, which make the satellite move on circular path. If gravity becomes 0, it will leave the surface. So gravity is not 0 there, gravity is there. But normal reaction, you can say normal reaction of the floor becomes 0, or the weight of man is balanced by central force. Wherever it is revolving, once there was question in Roorkee at entrance test, the satellite is moving at height equal to half radius of earth. कि भाई ये अर्थ है रेडियस ये है इतनी साइड इसके r by 2 में, तो what is the weight felt by man inside them? So wherever the orbit is there, it is at small height or large height, weightlessness will be there inside the satellite. This is very important. Then how to you can sleep there standing in standing position. When you want to take water, you will not be able to take water like this, because water will also not go to your mouth. You have to put water in a tube, you have to push in the mouth, and then you can take water inside, inhale. So that way, this is what there. Now, actually I was intending to tell you about so many things, but due to the time of video, here there is a limit of time here. Why the satellite is launched at such height? But there is a need of height of 30,000 kilometers for geosync satellite, because only it will appear at rest with respect to this at this height. polar satellites again are at 100, 800 to 600 to 900 kilometer up. Means they are to be launched above the atmosphere. Why? If we launch a satellite at certain height of 200 kilometer, the height of atmosphere is up to 400 kilometer. And if we launch the satellite in the atmosphere, the speed is tremendous. So due to tremendous speed, due to friction of air, kinetic energy of the satellite will be lost in the form of heat, and when it loses kinetic energy, that loss of kinetic energy is the cause of potential energy. So it will be coming closer and finally fall into the earth. Or due to friction, there may be large amount of heat which can burn the satellite also. So these are things. So please read the book, and I request you to have NCERT book with you. Other questions from the book I can write on the board or I can explain, but to become master in numerical physics, you need to do numericals. Without doing numerical, you will not be able to remember the physics. So when you watch my video, and I will be telling in the video, this is now I am doing question from NCERT book, this page and this exercise, so you can better gain the things easily and in small time. Because if I write the question here on the board, it takes long time, and video becomes smaller, and only I will be able to solve one question. So for this chapter, gravitation, now I have to do numericals, many numericals I have to do. So you should have NCERT with you. If you feel my video good, then share the video with your friend and ask your friend to subscribe my channel. Please, it will help me and you also.